Hello, everyone. Thank you for your patience. Yeah. Big applause to those guys. They fixed that. Thank you for coming here. My name is Patrycja, and today we are going to explore live Kubernetes hacking together. So get ready for a ride. But before that, a brief introduction. A little bit about myself. I've been doing professional software development for over 25 years. That's a quarter of a century. I do feel like a dinosaur sometimes. My first love was programming, but I betrayed my beloved Java a couple of years ago and got involved in the dark side of platform engineering. And that's why we have this talk today about Kubernetes hacking. So what am I going to talk about today? Just a splash of theory in the ocean of practice. So the key part of today's talk involves several demos. How many we will manage to showcase, we'll see. But those demos exploit different vulnerabilities in workload configuration or cluster configuration, and hopefully I show you how a series of simple misconfigurations can lead to a total compromise of the entire cluster. But first, let's start with Kubernetes architecture, just for all of us to be on the same page and to see which components we can target during our hacking. So there's two main concepts in Kubernetes: control plane and worker nodes. So control plane is like the heart of Kubernetes cluster. It manages the entire cluster. Here we have several components like API server. API server exposes this API which you as developer can use and interact with just to create, deploy, or update your resources. From the security point of view, etcd is a very important one. Why? etcd is a key value store where the entire information about cluster is stored. Think about your secrets. Once we get our hands on etcd, we can get access to any secret stored in our cluster. On the other hand, we have worker nodes. So basically, that's where the actual work happens and actual pods are running, right? So similar to API server, we have a kubelet on worker nodes. Each worker node has a kubelet process running. And kubelet is like a manager for this worker node. So it also exposes its own API. And again, think about security and authentication and authorization. If this API is not secure, then we can hijack it and tell worker node whatever we want. So basically to instantiate new pods or get access to existing pods, etc. On top of that, there is like CNI, also very important from the security perspective. Why? A CNI is a container network interface. So what does it do? In Kubernetes world, we have this overlay network. So Kubernetes makes guarantees that each pod can communicate with any other pod in the same cluster. How does it happen? Basically, overlay networks. So we need some sort of a network provider which guarantees and provides these capabilities. We have several CNI providers. Most famous one, I think, it's like Flannel, Cilium, and so on. How does this overlay network work? So basically, we create a virtual sort of network over a host network. And usually, it involves creation of several virtual network interfaces on each node. And then, via IP tables or eBPF routing, the traffic is forwarded from one pod to another. So once we get access to this overlay or host network, we can see those virtual network interfaces, and for example, we can sniff traffic. So that's another attack vector we are going to exploit today. How many of you heard about OWASP? Raise your hands, please. Yeah, a lot of hands raised. OWASP stands for Open Web Application Security Project. This is a non-for-profit organization which aims at increasing security awareness among developers. It all started with web applications, but nowadays it's spread into different areas, and one of them is Kubernetes. OWASP publishes those top 10 security risks for different technologies, and in 2022, they've published for the first time such a list for Kubernetes. And this is like a chart of top hitters and most popular vulnerabilities when it comes to Kubernetes deployments. So number one is insecure workload configuration. It involves any configuration like running as root, write-over-write system, security context configuration with those features like host PID or privileged mode. And many others. This is gonna be like one of the most used and targeted risk during today's demos. Another important one is missing network segmentation controls. K7. I've already mentioned this guarantee of Kubernetes that each pod can communicate with another pod in the cluster. So basically, it means that if you have different workloads deployed into the same cluster, like different applications, you need to provide segmentation between them yourself. K8 is also important, secrets management failure. Why? Because we need to remember that by default, the secrets in Kubernetes clusters are not encrypted. They are only encoded. So it's like having them in the plain text. Also, K9 and K10, they are like usual go-to risks when you are trying to target any Kubernetes cluster, like misconfigured cluster components or outdated and vulnerable Kubernetes or application components. So we will use those pretty heavily during today's demos. So that's it when it comes to theory. Let's move to the fun part, Kubernetes hacking. It's going to be like one-on-one course in Kubernetes hacking. So pretty simple one, but hopefully you will see how a series of simple misconfigurations can lead to a total compromise. I've prepared this demo application, and I will kindly ask you to register your accounts in this application. You can scan a QR code or access it under https://demo.yonlabs.com. Each account has secret data. Please register, log in, and wait to be hacked. My objective here will be like to hijack your accounts and learn your secrets. This is like a little bit of explanation. The QR code is still visible, so please feel free to register and log in. A little bit of a background for this application and what we will use here. So this is a JWT-based application. So it uses JSON Web Token to maintain a session between HTTP requests. So in such a case, there is like two main target vectors that hackers gonna use. One is to steal one of JWT tokens. One of JWT tokens generated by the web app. And another one is to, depending on a token algorithm, in our case, it's HS256, HMAC with SHA-256. HMAC means this is like a symmetric algorithm. So it means that the same secret is used to generate a token and then verify a signature. What does it mean? It means that we need to find the secret in order to be able to generate new tokens ourselves. So we'll try to steal your secrets, your tokens, or find out this one secret used by the app in order to hijack your accounts. So how are we gonna do that? Exploiting Kubernetes Open API, privilege escalation, pod escape, TCP, traffic sniffing, etc. So for you to better understand what's going on, just last slide on demo of application architecture. So basically, as a user, you connect to the application load balancer, which is in AWS cloud. You connect via HTTPS, so that's encrypted connection. But the application load balancer connects via HTTP only to a web server deployed in our Kubernetes cluster. And then there is application server also deployed in the cluster, as well as a database and Redis server. Redis is used here to store invalidated tokens, JWT tokens. Because what's the problem with JWT tokens as an authentication mechanism? The problem is that there is no way to invalidate them. So again, developers need to implement own mechanism for session invalidation. And usually it's implemented as once a user clicks logout, such a token is stored in some sort of storage, in our case, Redis. And then during logging in, when the same token is reused, it's rejected as invalidated. Okay, so let's start our demo. Let me see first how many of you managed to register. Okay. Oh, quite many of you, so many accounts to hack. Thank you for your cooperation. Okay, so I will do all the hacking from my evil server. I'm logging in now. And the first thing usually hackers do is some sort of a reconnaissance. So basically, checking out all the ports and sniffing what's listening on those ports. They usually use tools like ncat or nmap. Here we are targeting Kubernetes clusters, so we will use dedicated tool, which is Kubelet Cattle. Kubelet Cattle is a wrapper around Kubelet API. So we are targeting worker nodes and trying to see whether or not there is an open API on worker nodes. There is a scan command available. I need to provide a CIDR. CIDR is just like a range of IP addresses I need to target. And let's do some scanning. First, I need to clear, okay. Because I have some other demo prepared. Okay. So we found 2 worker nodes with open API. What can we do that? Basically, this is a basic REST API. So we can connect to it just like that. And so you can see this is like a JSON response, but to show it in more like readable format, I will use JQ and just to show you pod names. So basically, those are the pods running on this node. So we are targeting our demo application, so most likely this is gonna be this pod or this one. So we have quite a few available. What can we do more? With Kubelet Cattle, we can scan for remote code execution. So basically, it will tell us which pods can execute commands. Okay, that's a typo. So here we see that we have quite a few, almost all the pods. On all the pods, we can execute commands. So basically, it just tests whether ls is possible. But instead of ls, we will try to execute other commands. So Kubelet Cattle, exec, and I will try just to test to execute whoami command. It will tell me which user this command is executed under. So I'm targeting my demo server pod. So that's namespace backend and container demo, and I need to provide all those parameters, including server. Okay, that's very handy because it means that this pod is running as root, so we have a lot of options available here. And such an option, usually when a hacker sees any remote code execution possible, it goes for a reverse shell. What is a reverse shell? So think first about how you want to connect to a remote machine. So you SSH to a machine, you provide your credentials, and you are given a shell, right? Reverse shell is the other way around. So instead of a client machine connecting to a remote machine, the remote machine connects to a client machine and exposes a shell. This way, we bypass this credential verification step. So in order to create a reverse shell and get access to this pod, I need to have a process listening on some server. I will use my evil server. So I need another terminal session. And I will just run nc command. So basically, I'm listening on this port, 4444. And here, instead of whoami command, I will execute nc to my evil server. And that's an IP of an evil server with this port. And I will tell it to execute shell. Okay, and you see that I've received connection here. And basically, I'm in. What can I do here? Basically, again, some sort of reconnaissance, checking mounts, perhaps any host volume is mounted. It's not. Usually, it's good to see if TCP dump is available just to sniff traffic. We are on the server, so the server receives connections and processes the requests, HTTP requests. So I would like to run TCP dump. Unfortunately, TCP dump is not available, but let me check if this is a writable file system. Yes, it is writable file system, so I can try to install TCP dump. Usual APK packet manager is available. So I will add TCP dump and I will run TCP dump. And here I know which port I want to target. It's 1990. Obviously, I would need like some tooling to find it out or some sort of reconnaissance. It's not like rocket science. Okay, so I'm starting TCP dump here. And now kind request to you, please refresh the pages in our demo web app. This way, I will get your request, and we see a lot of requests coming in. Oh, thank you, you are very active. Okay, and here, let's take a look at HTTP headers, and we have this authorization bearer header, which basically stores JWT tokens. So now I'm copying this token and moving back to my browser. And instead of my token, I will paste one of yours. Refresh the page, and Mari, you've been hacked. Are you here, Mari? Yeah, thank you for your cooperation. So that was our first demo, and we had several problems here. The first one was Open Kubelet API. And if you take a look at the Kubernetes docs, you see that those are the defaults. So anonymous authentication and authorization mode always allow, those are the default. The good news is that usually you don't install Kubernetes manually. You use some tooling. You use managed Kubernetes in clouds, or you use like Kube ADM to install Kubernetes, and those have secure defaults. but like plain Kubernetes has those defaults different. So we had K9 misconfigured cluster components with Open Kubelet API. And another problem was K1 insecure workload configuration. When it comes to our demo server application, we had privileged actually, the main problem was like, this is the wrong slide, because the main problem was running as root, writable file system, and quite a few tools available, because we had NC to create a reverse shell to our evil server. So those were the main problems when it comes to K1 insecure workload configuration. And when it comes to networking, we had unencrypted traffic and open egress to internet. Open egress to internet, we exploited it during installing TCP dump. So packet manager had to connect to the internet in order to download TCP dump package and install it. So those were the main problem. Okay, let's move on to another demo. Here we have another application deployed in the same cluster. This is a simple hello application, so it says hello when you type something here. And it has remote code execution vulnerability. What does it mean? So basically, it means that we can execute other commands via this interface. So here you see that I've executed whoami command. It shows www.data. And how can we exploit it? Again, as I told you, when we see remote code execution, then let's go for a reverse shell here. So we are on the evil server. We need nc command to listen here. And we need like a command to connect and create a reverse shell. So instead, whoami, I will execute nc and expose bash. Okay, so you see connection received, so we can focus here. And as I said, the first thing is like some sort of reconnaissance, just to speed things up. I do have some cheat sheet available here. So here we have scanning for open ports. And let's see what's going on here. So we see here that there is Redis running in the same cluster. How can we exploit it? First, we can check it out. Redis uses this RESP protocol, Redis Realization Protocol. Basically, it's kind of a text-based protocol. So we can execute this ping command. We received Pong, so basically we have access to Redis. What can we do here? We can see all the keys in Redis. There is nothing here now, but I will ask you, please log out and log in again in our demo app. Then I will get some data to work with. So please, yep, we have the first one. So basically, this person with this token, they logged out from the app, so this token is invalidated. It's invalidated, so if I try to use it, it will be rejected. However, this invalidation is only like via storing in this Redis storage. So I can remove this token from storage and try to use it. It should give me access. Okay, so I've deleted the token, so I need the token itself. And again, you know the drill, just replacing the token. And Cobe, you've been hacked. Are you here, Cobe? I don't. Yeah, you are over there. Thank you. So you've seen another set of problems when it comes to Kubernetes and its application. First of all, an RCE, remote code execution vulnerability in one Kubernetes workload caused that the other workload was accessible, because this was like two workloads, our RCE web app and our demo web app apps deployed in the same cluster, and the vulnerability in one of them caused the problems and exploitation in the other. Why did it happen? Because we had the problem K7, missing network segmentation controls. So basically there were no segmentation configured, no network policies configured. So hello RCE pods could connect to demo pods, being it server or, in our case, Redis server. Again, quite a few tools possible, like NC on our RCE Hello app, plus anonymous access in our Redis server. Let me check. We still have a bit of time to do more demos. So let me move back to my evil server. Now I will change the context to John Doe. John Doe is a user who has access to the Kubernetes cluster, but it has a limited access just to manage FUAP namespace. And he's able to create pods and exec into pods, and as well as deployment. I have this manifest prepared. This is, let me show you in more readable way. So this is like a very simple manifest to spin up a new pod. And here we have host PID set to true. This means that this pod will have access to process ID namespace of the underlying node. And we have security context set to true, and moreover, we are trying to schedule a pod on the control plane. Okay, so let's apply this manifest. We have a new pod created. Let's exec into this pod, and this is FUAP namespace, and we need a bash. Okay, we are on the pod. So what can we do here? We have pretty wide privileges. Privilege true is like you should never assign it to any pod or any of your production workload. It's like very, very rare cases when it should be available. But we also have access to this host PID. So basically, when you think about Linux security mechanisms, namespaces are like the basic fundamentals of Linux security. So to access and break out of your sandbox, like pod sandbox, you can enter into another namespace. And we want to enter the namespace of our target PID is 1. Why? Because, let me show you. This is the systemd process. This is the first process in the Linux kernel. So basically, when I enter its namespace, it's like I'm the root on the host. So I'm trying to enter namespaces of all namespaces of this first process. And here you already see that something changed. You see this by the prompt, but let's do uname. So basically now I'm on the host. What can I do here? I should be scheduled on the control plane, so I should see etcd process. Yes, I do see it, and I see data there. I told you that etcd stores the entire cluster information. So let's try to access it. Okay, and this is basically this file. You can see the data, and they are pretty visible when you use strings command. So let's search for secrets. We do have some secrets, and luckily for us, and surprisingly, right, we have those demo secrets available, so most likely from our demo app. Let's see wider context. And here we have JWT secret key. So let's try to use it. How can we use it? So basically, we can use this jwt.io web page. Let's copy some existing token just to see the structure. You see that it uses HA256 algorithm. We have several claims. Basically, the subject claims identifies a user. So here we have an ID 12. But we have invalid signature because we don't have a secret. But luckily for us, we can copy it from here. And let me see it. It doesn't work yet, but we need to change to base64 URL encoded. And we are ready to replace the subject. So let's change the ID. We have a new token available. So we basically generated a new token. So now we need to replace it and refresh. And Mozi, you've been hacked. Are you here, Mozi? I don't see any hands. Yeah, perhaps over there. But thank you for your help. So several problems here. Privileged, don't use ever, never ever. Host PID, basically any extra privileges, you need to think twice and never run as root. So that was the problem here. And hopefully I want to show you one more demo because this one is pretty cool, I think. Okay, I need to get back to my evil server. Okay, that's my evil server, and we have the fourth demo. Here we don't use privilege. configured in security context, but instead we use security context capabilities. Like we use this sys module capability. Basically, this allows to load new kernel module. So this is also pretty wide privilege, and never ever use it in real life. Okay, so let's apply this one. Okay, that's created. Let's try to exec into this pod in this namespace. Okay, we need to execute something. Okay, so here I have this ref shell module prepared. This is a C file when we implement a new kernel module. This is a very simple implementation. It needs to expose two methods, init mode and exit mode. This init mode basically starts a reverse shell. So here to start a reverse shell, we use bash, not NC, but still this is the same basically concept. So we are connecting to an evil server and trying to connect to this port. So in order to run this one, I need to start some process listening on my evil server on this port. So I'm ready here. So what can I do here? I need to compile this module and I need to load it. So I'm using inst module to load this module. And I'm in. What can I do here now? So basically, I'm not on the control plane now. I'm on a worker node. And here I can use crycatl PS to just see all the pods running on this module. And I do see this demo server, which I want to inspect in details via crycatl and get PID of the process. Why? Because when I'm on the node itself, I can see configuration environments, all environment variable of this pod via proc file environ. So you see it here. It's not very readable, but let me just apply this command to make it readable and introduce new lines. So basically, again, I have the secret key. Here, it's not URL encoded because it was URL encoded in etcd, but here it's like decoded, so we see it plain text, and we can use it again. And here in the code, we can copy this and change to just UTF. And again, you see that's like a valid key. So let's try maybe 5 this time. And hopefully, last demo today, just to refresh, and Castafili, you've been hacked. Okay, so that's it when it comes to demo. I had 2 more of them prepared, pretty cool ones, but you need to wait. I can only tell you that when it comes to Kubernetes security, it was the tip of the iceberg. So there is more and more problems involved in Kubernetes security. We need to remember about Swiss cheese security model when we have those different security layers configured like stacking the slices of cheese in order like just for one layer to cover the holes in another layers. So remember that 100% safety guarantee is not possible. It's only to provide more robust defense mechanism and to make it more challenging for bad guys to exploit our workloads, and to make it like more easy for us good guys to detect any attack attempts or any threats. Remember that a fool with a tool is only a fool, and we shouldn't be fools. We should know our tools, and that's why we need to keep educating ourselves. And that's the paradigm of continuous learning, and that's what conferences are all about. So hopefully you've learned something useful today and you enjoyed the talk. So thank you for your cooperation. And once again, thank you for your patience and waiting after technical troubles. And once again, thank you for our technical guys for solving them.